All right, here's problem set number 5. We've got 3 problems. Go ahead, try them on your own, and when you're ready, go ahead and look at the solutions, compare them with your own, and watch the video if you need more extra explanations. So in this first problem, we're given the feasible region of a constrained optimization or linear programming problem. So we know it's sort of the setup that we're used to. And we want to find both the minimum and the maximum of this objective function 3x plus 2y. So we remember that the minimum and maximum can only occur at these corner points as long as we have a bounded region, which we do, right? It doesn't go infinitely far in any direction. And that the boundaries are all enclosed. So I don't have any dotted lines, so I'm ready to go. So the minimum and maximum can only occur at those points. So I'm going to make a table here. X, y for my points, and then the objective function 3x plus 2y. So for the first point, negative 1, 1. I plug that in, I get negative 3 plus 2 is negative 1. The second one, I have the point 2, negative 1. Plug that in. 6 minus 2 is 4. And then the last point, 0, 2. Plug that in. 0 plus 4, also 4. So that tells us that negative 1 is the minimum. And it occurs at that point, negative 1, 1. And then 4 is the maximum. And remember, if there's a maximum that occurs at 2 different points, it also occurs at every point along that. So my maximum is actually going to occur everywhere along this line. So it occurs along the line from 0, 2 to negative 1. So everywhere along the line is where that maximum value occurs. Okay, in this next question, we're given a probability tree. Oh, there's a little problem with this probability tree. Let me go ahead and fix that, and I'll fix it on the initial slide. I want to make sure my probabilities on each branch add up to 1. And we're asked to find a bunch of different probabilities. So the first one that we want to find is the probability of A and C. So that means I need A to happen and C to happen. So to find those probabilities, I'm just going to multiply along that branch. So that's 0.1 times 0.3. So I get 0.03 if I multiply those two. Next, I want to find the probability of A given C. So given C, C doesn't occur is the first thing. So this is one where I need to use Bayes' theorem because I haven't broken things down by C first. I've broken them down by A and B first. So I know that the probability of A given C is the probability of A and C divided by the probability of C. So the probability of A and C, we already did that. That's 0.03. For the probability of C, I need to think about all of the different paths that take me to C. So I can either go B first and then C, or sorry, A first and then C, or B first and then C. So A first and then C, we know that's that 0.03. For B first and then C, I get 0.9 times 0.4. So that gives me 0.03 over 0.03 plus 0.36. So that's 0.03 over 0.39, which you can see maybe that's going to reduce down to 1 over 13, and then you can use a calculator to find out what that is going to be as a decimal approximation. For the probability of C given A, C given A, that just tells me I want to figure out how likely C is to occur, given that I already know A occurs. So that's a value I can read directly off my Traeger diagram. So that's just going to be 0.3, right? So that's C given that A has occurred. So I know I go to the A branch. I know I'm on that A branch. So I'm sort of sitting here at A. And then from there, I just look at the likelihood of C. So that just gives me that 0.3. All right, let's see what else we have. Probability of A. the probability of A, right, I'm just starting at the beginning. I want to know how likely A is to occur. So that's just 0.1. So we can read that off the table. And then the last thing we have is that probability of C. We actually had to calculate that up here. So that's that 0.03. So that was A then C plus 0.36. So that was B then C, because those were the two different ways. So that gave me that 0.39 for that probability. So you need to make sure you can be able to identify any of these different probabilities from your probability tree. Okay, so this question is about matrices. So if you haven't gotten to that section yet, make sure you recover that before you sort of get back to this question. So I have a 3 by 2 matrix. So let's just remember what that means. The first one tells me the number of rows. So I have 3 rows and then 2 columns. So it's going to be 3 by 2. And I want to know if there's a matrix B that can both be added. So I want to do plus B and multiplied. So times B. But, right, for B to be added, I need it to be the same size as B. So B must be 3 by 2. But if I have my A, which is 3 by 2, and then my B, which is 3 by 2, I can't multiply them because the 2 and the 3 don't match. But maybe I could do it in the different order. So if I had B, which is 3 by 2, right, and A, which is 3 by 2, I still can't multiply. So there's no size that we can have for B so that I can both add it and multiply it. So no such B exists. So we need to make sure we know which sizes we can add together and which ones we can multiply.